A visitor from beyond the stars is racing through our solar system, and it's unlike anything we've ever seen. New images from Mars are giving scientists an unprecedented close-up of 3I/ATLAS, revealing a massive, mysterious object that challenges everything we thought we knew about interstellar comets. How big is it? Where did it come from? And could it actually be a seed for planet formation? Buckle up, because we're about to dive into the extraordinary journey of this cosmic interloper, a stranger in the dark. It began with a flicker, nothing more than a tremor in the darkness that most telescopes would have missed. At first, the data looked routine, another streak of light catalogued and forgotten among thousands of wandering specks. But one quiet night, as the instruments of the Minor Planet Center stitched together their readings, a faint anomaly appeared, a trajectory that refused to behave. The object drifted not like debris, but like something with memory, steady, deliberate, and impossibly poised. They named it 3I Atlas, a title that sounded technical but soon carried the weight of legend. Across continents, observatories pivoted their domes to follow the intruder. From Mauna Kea's silver ridges to Chile's parched summits, astronomers watched a point of light slide across the void, growing brighter yet oddly stable. Most comets quiver as sunlight batters their fragile shells. They tumble, outgas, and weave erratic paths. Atlas glided. Gravity tugged, solar wind hissed, but the visitor seemed to shrug off every touch. Each new measurement deepened the riddle. The expected acceleration simply wasn't there. It was as if the universe itself hesitated to move it. In mission control rooms and coffee-stained offices, scientists argued in whispers. Could the data be wrong? Was there calibration drift, an optical ghost in the detectors? But night after night, the same quiet defiance returned. Atlas didn't flinch, didn't brighten erratically, didn't fracture like its cousins. Somewhere in the hum of machines, curiosity began to outweigh caution. Someone muttered the word massive, someone else said unprecedented. Within days, the whispers reached Harvard. The excitement was different this time. It wasn't the thrill of discovery, it was the unease of recognition. The feeling that something familiar had taken a shape it shouldn't have. Astronomers had seen heavy comets before, but never one that travelled this far from any star, carrying such composure. If it had journeyed through the interstellar gulf for eons, battered by cosmic rays and magnetic storms, how did it arrive so intact, so deliberate in motion? Every telescope image showed the same quiet dignity, a brightness that seemed to pulse with purpose. Reporters tried to translate the data into headlines, but even the boldest adjectives felt too small. This wasn't merely large or rare, it was impossible by the standards written in every textbook. For centuries, humanity had trusted the equations that defined motion, force, and mass. Now, a lone traveller from beyond our solar system had appeared, carrying a question those equations couldn't answer. What secret strength allows a wanderer born among the stars to move as softly as light itself? Stay with us as the mystery deepens. The weight that wouldn't yield. Weighing a comet is like trying to catch smoke with your hands. You see the shimmer, not the substance. When 3I Atlas crept closer to the sun, astronomers expected the same spectacle they'd seen 100 times before. Ice turning to gas, vapor jets hurling dust outward, until the fragile heart disappeared behind its own luminous veil. But beneath that glowing disguise, something refused to behave. The data didn't lie, it hesitated. Gravity tugged, sunlight streamed, and still the object moved as though carved from intention itself. At Harvard, 3 minds joined around the puzzle: Richard Kluder, Avi Loeb, and Peter Vess. They combed through months of measurements from observatories scattered across Earth: Hawaii, Chile, Spain, and Arizona, each a tiny echo of the same defiance. They ran the orbit through every simulation known to the celestial mechanics. The result was always the same. Atlas's trajectory deviated only slightly from a perfect gravitational curve, too little for the amount of vapor it was shedding. A comet this active should have been jittering through space like a firework. Instead, it sailed like a planet on rails. The numbers whispered their truth. For jetsets of escaping gas to push so little, the nucleus beneath had to be astonishingly heavy. Billions of tons, perhaps tens of kilometers wide. Not a snowball, but a mountain. Imagine Everest frozen, cast into space and sent drifting between the stars. That was Atlas, a fragment of a world masquerading as a wanderer. The discovery rolled through research circles in a hush at first, because numbers that bold invite disbelief before they invite awe. But disbelief gave way to silence, and silence gave way to a new fear. What if this wasn't an exception but a revelation of how little we really knew? One scientist described it best. It moves as though it remembers being part of something larger. That single sentence found its way into late-night conversations, into podcasts and blogs hungry for mystery. Was Atlas a shard of a lost planet, ripped from its birthplace by some ancient cataclysm? Had it wandered light years only to brush against the edge of our curiosity? The idea of such endurance, of a body surviving eons of cosmic punishment without losing its form, was intoxicating. It forced astronomers to look not only at the data but at themselves. If the universe could hide such weight inside what looked like a comet, what else might it be concealing? The world has always gazed upward, searching for wonder, but now wonder was staring back, massive and motionless, gliding through sunlight as if daring us to guess its origin. Could something so immense, so perfectly balanced, really be just another rock adrift in the dark, or was it carrying a purpose we'd yet to imagine? Follow us to discover more. The Equation and the Whisper. By the time the Harvard team released its preliminary calculations, the astronomical community had already begun to hum with quiet tension. The numbers were out there, solid, unblinking, impossible, and it was only a matter of time before someone asked the question that would tilt the conversation from science to speculation: that someone, predictably, was Avi Loeb. For years he had carried the reputation of a man who refused to let mystery sit quietly. Where others saw an outlier to be filed away, he saw an opening to wonder. So maybe, when he examined the reports on 3I Atlas, the minute deviations in its orbit, the strangely metallic spectral lines, the stubborn consistency of its path, he found himself leaning closer to the screen, his pulse quickening not with fear but with recognition. To Loeb, anomalies were not annoyances, they were the universe clearing its throat. The data hinted at nickel without the iron that should accompany it, a ratio that made no chemical sense for a comet. It was as though the material had been refined, purified by processes more deliberate than volcanic or cosmic accident. He noticed too how the object's trajectory seemed uncannily precise, slicing through the inner solar system as if plotted by hand. When he raised these points in a faculty meeting, the room fell into the kind of silence that always follows a dangerous idea. A younger colleague laughed it off as poetic coincidence. Another warned that even whispering such possibilities would invite ridicule. Loeb only smiled, the kind of half-smile that belongs to a man who has already decided that curiosity matters more than comfort. Outside academia, stories move faster than caution. A science blogger caught a fragment of the discussion and framed it with the irresistible headline, "Harvard Professor Hints at Alien Engineering." Within hours, the internet caught fire. Radio hosts debated whether Atlas was a derelict probe, a cosmic messenger, or merely the imagination of another eccentric genius. NASA released a carefully worded statement emphasizing natural explanations, but restraint rarely triumphs over romance. The notion that something intelligent might have crossed the interstellar gulf and brushed our solar system, cloaked in ice and mystery, was too intoxicating to die quietly. In quiet moments, even Loeb questioned himself. Late in his office, with the hum of the campus fading into night, he stared at the scatter of data points glowing on his monitor. The evidence was thin, circumstantial whisper light, yet it refused to vanish under scrutiny. He wondered whether humanity's skepticism was simply a fear of significance, a defense against the possibility that we are not alone. The line between scientific caution and existential dread had never felt thinner. Every discovery forces a choice, to dismiss the unknown as noise, or to listen for the pattern within it. And somewhere, out beyond the reach of radio and reason, 3I Atlas continued its steady glide, indifferent to our debates, carrying its unanswered riddle deeper into sunlight. Was the universe teasing us with coincidence, or had we just glimpsed the signature of another mind at work? Let us take you through the secrets. Seeds of creation. While the debate over Atlas's origin stormed across universities and talk shows, one voice approached the mystery from a quieter, almost poetic angle. Dr. Suzanne Folsner, an astrophysicist known more for her patience than her provocation, watched the growing uproar with a kind of calm fascination. To her, the question was not whether Atlas had been built by someone, but what purpose nature itself might have written into its making. In the amber glow of her office at the Max Planck Institute, she opened an old simulation file and began to rerun the code she had first written years before. Models of young stars wrapped in glittering disks of dust and ice. Those disks, she knew, were the wombs of worlds. They spun like luminous rings of smoke, each particle colliding, sticking, shattering and reforming in an endless ballet. Over millions of years, a few grains became pebbles, pebbles became boulders, and eventually the boulders merged into the planetary embryos called planetesimals. But her equations always revealed the same cruel limit. The process took longer than the gas in the disk could survive. Before giants like Jupiter could grow, the gas would blow away, leaving the system barren of large worlds. Unless, she thought, something came from outside to tip the balance. What if the universe had a shortcut? What if every so often, a traveller like Atlas drifted in from interstellar space, a ready-made core, dense and heavy, falling into a new system just in time to seed creation? With that single addition, the math changed dramatically. Gas and dust would spiral toward the intruder, feeding it, swelling it into a gas giant in a fraction of the usual time. A lonely wanderer could become the heart of a newborn planet, a catalyst for order in a sea of chaos. Falsner's simulation proved more than plausible. It was elegant. Larger stars with stronger gravity captured more interstellar visitors, and indeed, observations showed that larger stars hosted more giant planets. The correlation gleamed like a cosmic signature. Perhaps the galaxy was not a collection of isolated systems, but a vast nursery where fragments of one world became the seeds of another. Each interstellar comet could carry the memory of ancient suns, sowing life and structure wherever chance allowed. When she presented her findings at a small symposium in Vienna, the room grew still. Even the skeptics seemed moved by the poetry of the idea. Maybe 3i Atlas wasn't a spy from another civilization, as Loeb suggested, but something grander, a gardener of the cosmos, passing silently from system to system, ensuring that creation never stops. And if that were true, then perhaps our own planet owed its beginning to such a stranger long ago. Could it be that every world, even our own, is born from the ashes of another? Come with us as the secrets grow even darker. A tour through fire and ice. By the time scientists understood how strange 3i Atlas truly was, it was already on its way toward the inner solar system, a slow, deliberate glide that felt almost rehearsed. For once, humanity had time to prepare. There would be no guessing after it was gone, no desperate scramble to reanalyze old data. Every agency, from NASA to ESA to independent observatories, locked their instruments on the traveller. Its journey would be mapped in detail, milestone by milestone, like the itinerary of a cosmic ambassador passing through foreign lands. The first landmark was October 3rd, 2025, when the object was set to brush past Mars. Dawn over Valais. Marineries painted the canyon rims gold as orbiters turned their cameras toward the faint glimmer approaching from the black. What they saw was subtle but mesmerizing, a blush of pink around the nucleus, a faint shimmer that grew brighter as the sun rose over the red planet's horizon. Data streamed back to Earth in slow, steady pulses. For the first time, we watched an interstellar visitor through the eyes of another world. A week later came October the 10th, the perihelion. Atlas would swing behind the sun, slicing closer than Mercury's orbit. Probes tracked its blistering speed, nearly 1 million kilometers per hour, as jets erupted from beneath its crust like geysers on fire. The energy release was staggering. Cameras aboard the European Space Agency's Mars Express and the ExoMars Trace gas orbiter caught ultraviolet arcs dancing around its silhouette. The comet blazed white-hot for only hours before beginning its long outbound climb, trailing ribbons of vapour like the tail of a burning god. December the 12th marked its closest approach to Earth, 50 million miles, safely distant yet tantalisingly near. To the naked eye it was nothing, but through the James Webb and Rubin observatories, the view was transcendent. Its tail stretched like silk, streaked with faint spectral fingerprints of carbon, water and something more elusive, traces that didn't quite fit the known chemistry of comets. The data wasn't proof of anything unnatural, but it hinted at unfamiliar processes, perhaps minerals forged in the furnace of another sun. The scientific community held its breath, waiting for clearer results. Then came the grand finale, March 4th, 2026. As Atlas drifted past Jupiter, The Juno spacecraft adjusted its orbit, angling its sensors toward the edge of the dust stream. For a few brief hours, it would cross paths with matter older than the solar system itself. Engineers compared it to a handshake across eternity, a fleeting touch between two wanderers born in different skies. No one could predict what Juno would find. The spacecraft's dust analyzer waited in silence, ready to taste the debris of another galaxy. After that, Atlas would vanish into the outer dark, leaving only data, questions, and a silence heavy with wonder. For all our preparation, we still didn't know what we had just witnessed. A natural wanderer, a messenger, or something entirely new. What would humanity do if the universe had just waved back? Stay tuned as the next twist unfolds. Echoes before the storm. Even before the grand celestial tour of 3E, Atlas was over, a strange hum of anticipation spread through the scientific community, an unease that no amount of data could soothe. Every telescope had done its job, every agency had their numbers, yet something in the reports didn't add up. Behind the official press releases, whispers began to ripple through internal chat rooms, quiet emails, and late-night calls between colleagues. The story, it seemed, wasn't finished. It was only beginning to bend into something more human, something emotional, uncertain, and far harder to contain. It started with a single image. During the Mars flyby, an analyst working the night shift at the European Space Operations Centre noticed something odd in a filtered frame from the ExoMars Trace Gas Orbiter. The comet's coma glowed faintly blue, an impossible colour, since comets rich in carbon dioxide normally shimmer green when excited by solar radiation. The analyst flagged it as a calibration issue, but curiosity, that old seducer of reason, made them save a copy before discarding the line of code. Within days, the image quietly circulated through private forums. By the time it reached an independent researcher, the rumour already had its wings. A blue comet near Mars, unlike anything seen before. At first, the public never heard a word. NASA and ESA kept their silence as they always do when results are still uncertain. But silence is an unstable thing. One anonymous post, one screenshot taken out of context, and suddenly social media burned with the story of an interstellar object emitting blue light near Mars. Scientists scrambled to clarify that it could simply be sensor noise, data compression, or a spectral glitch, but the internet has never been a patient audience. Forums filled with theories, alien propulsion systems, mineralized metals, even dormant probes hidden beneath layers of ice. For the professionals tracking the real data, the frenzy was exhausting. But deep down, many couldn't deny the thrill. What if just once the wildest explanation turned out to be true? What if the strange blue glow wasn't a mistake but a message? A subtle hint of composition or structure unlike any comet we'd ever known. Those thoughts, unspoken but persistent, echoed across labs and offices, keeping even the most disciplined minds awake at night. In the weeks that followed, official statements began to blur the line between caution and secrecy. Schedules shifted, reports were pending further verification, and as Atlas drifted beyond the orbit of Jupiter, the world began to sense that something was missing, some detail quietly withheld, some truth too fragile or explosive to release. The data blackout didn't stop the questions, it multiplied them. Every great discovery cast a shadow before the light. For Atlas, that shadow was just beginning to stretch across our imagination. The object had already left our skies, but its echo was only growing louder. Could the silence itself be the message the universe wanted us to hear? Let us tell you, the leak nobody expected. The silence never lasted. It never does. After the weeks of unanswered questions and tight-lipped statements, the story of 3I Atlas burst back into view, this time not from an observatory or a press room, but from a laptop screen in a dark apartment somewhere in Berlin. The technician's whispers about the blue smudge had drifted through private channels for days, and now the rumour found its amplifier, a data stacking enthusiast named Simeon Schmaus. He claimed to have reconstructed the leaked Mars images using open-source software. The result was haunting. A soft cobalt flare glimmering above the Martian horizon, right where Atlas should have been. It wasn't proof of anything, but it looked like everything. Within hours, the image ricocheted across astronomy forums, Discord servers, and social media threads devoted to planetary imaging. People zoomed, filtered, enhanced, and argued, Was it dust scattering sunlight? Was it a digital ghost born of compression? Or was it, as one poster breathlessly suggested, the reflection of an object that shouldn't exist? Each refresh brought new believers and skeptics, their words colliding in real time across continents. Somewhere inside Harvard's physics department, Avi Loeb's phone began to vibrate non-stop. He hadn't shared the image, hadn't verified it, but his name had already been attached to it. A quote taken from a months-old interview, "We must never ignore anomalies," was pasted beside the picture on blogs and YouTube thumbnails. The implication was irresistible. The professor who once speculated that Oumuamua might be artificial had just been handed another cosmic riddle. By sunset, hashtags like #AtlasOverMars and #BlueComet were trending worldwide. Every television anchor wanted an answer. Every newsroom wanted Loeb. Inside NASA's Jet Propulsion Laboratory, the atmosphere turned brittle. Engineers confirmed that the data used by Schmaus did originate from the ExoMars Trace gas orbiter's feed, but they also knew how easily colour channels could mislead the untrained eye. To them, the blue was probably a calibration slip, a hiccup in the algorithm that translated raw numbers into light. Still, the optics were disastrous. How do you convince the world that the most exciting image it's ever seen is a mistake? The more officials insisted that nothing extraordinary had happened, the more extraordinary the denial itself appeared. The narrative had escaped its authors. Atlas was no longer a scientific object, it had become a story, a myth in motion, feeding on speculation faster than light. Commentators called it the first interstellar PR crisis. Others simply called it destiny, a moment when the universe forced us to look, even if we didn't understand what we were seeing. The image wasn't proof, but it was a mirror, reflecting humanity's hunger for significance in the silence between stars. Was the mysterious blue shimmer a glitch of machinery, or the first hint that the cosmos was ready to answer back? Come with us to know the colour that changed everything. By the following morning, the image had escaped gravity itself. Every corner of the digital world pulsed with the same electric hue, screens awash in that impossible blue. For years, scientists had explained that comets rich in carbon dioxide shine green under solar radiation. Never blue, never pure. Yet here was Atlas, a ghostly sapphire hovering above the rust-coloured plains of Mars, defying everything textbooks promised. It didn't matter that experts called it an artifact of overexposure. Beauty makes its own truth. The picture was too perfect to doubt. News outlets turned the anomaly into theatre. Morning hosts argued over saturation filters, while late-night pundits joked that NASA had finally photographed a cosmic traffic light. Somewhere in between, genuine curiosity began to bloom. For a moment, science wasn't confined to journals, it was alive in the chaos of conversation. But the very colour that had awakened wonder also lit the fuse of paranoia. Why, people asked, had the agencies reacted so defensively? Why had some of the raw files suddenly disappeared from open databases? A pattern began to form, not in data, but in human imagination. At Harvard, Loeb tried to stay disciplined. In a brief interview, he urged caution, reminding reporters that light can deceive, that instruments sometimes paint illusions when pushed beyond their limits, but restraint rarely trends. A clipped quote, "The phenomenon deserves serious investigation," became tomorrow's headline. Harvard professor confirms blue comet mystery. His inbox filled with invitations, threats, and declarations of belief. The narrative had slipped from the hands of those trained to hold it. Meanwhile, a storm brewed inside NASA and the European Space Agency. Private Slack messages leaked, revealing quiet frustration among engineers who feared the public had already chosen its miracle. One post simply read, "The story has momentum now. Physics won't stop it," and it didn't. YouTube channels analysed every pixel. Podcasts dissected Loeb's past research. Conspiracy pages declared that the colour blue matched ancient depictions of sky gods. The internet had turned a calibration artifact into mythology. Yet even amid the noise, a few voices whispered something simpler. What if the image, exaggerated or not, hinted at chemistry we hadn't catalogued? New isotopes, exotic ices, a process we'd never observed up close. That question, quietly scientific, found little space in a digital world built for spectacle. The mystery had become entertainment. and entertainment rarely leaves room for patience. Still, somewhere between data and dream, a sliver of possibility endured. Maybe that flicker of blue was neither proof nor hoax, but an invitation, a reminder that the cosmos owes us no explanations, only questions. What if the colour that once divided the world is now what reignites our shared curiosity? Stay with us as the secrets grow even darker. The internet burns. No one could pinpoint the moment when fascination became frenzy. But by the second week of October 2025, the world had stopped discussing 3-Eye Atlas as science. It had become something far more volatile, a story everyone wanted to own. The blue image, copied and reposted millions of times, no longer belonged to the realm of data, it had entered culture. On Reddit, users tore apart every pixel like detectives at a crime scene. One thread titled "NASA's Hidden Frames" hit 500,000 comments overnight. Its top post claiming that earlier photos had been deleted from the agency's servers. Others swore they had downloaded files that mysteriously vanished from their drives. YouTubers dissected the rumours with slow-motion graphics and whispered conviction, drawing millions of views. Even the skeptics became fuel for the fire, their calm explanations replayed as evidence of a larger cover-up. Every few hours, a new theory ignited. Some said the object's blue glow came from superconducting alloys impossible in nature. Others insisted the reflection pattern matched the metallic panels of an ancient probe. A fringe community built entire 3D reconstructions, claiming the nucleus resembled a hexagonal structure. The most imaginative post declared that Atlas was a vault, a repository carrying the seeds of civilizations, finally awakened as it passed near a world capable of recognizing it. Within days, mainstream media caught up, not to extinguish the flames, but to feed them. Every channel needed its own spin. On one network, a panel of physicists argued over pixel values. On another, a former intelligence officer hinted darkly that certain discoveries were classified to protect public stability. Talk shows joked about Martians with tasting colours. Late-night comedians built monologues around #BlueComet, and behind every punchline, the mystery thickened. The more experts explained, the less anyone wanted to listen. Rational voices were drowned by the hunger for wonder. The internet had become a living organism, devouring facts and exhaling stories. Algorithms, sensing the public obsession, kept serving more content, each post louder and more speculative than the last. By mid-October, billions of people had seen the image. Many couldn't remember where they'd first found it, only that it felt important, urgent, like the prelude to revelation. Inside the agencies, tension rose. Private emails leaked. Some scientists admitted they were afraid to speak publicly, knowing that any quote could be twisted into prophecy or proof. Others were simply exhausted. "We've lost control of our own discovery," one ESA engineer confessed anonymously. "The world is watching a ghost and arguing about who it's haunting." Even Loeb, who had spent years weathering controversy, found himself cornered. Invitations to primetime interviews arrived hourly. Online petitions demanded he be put in charge of an independent inquiry. When he refused, the narrative twisted again. Harvard professor silenced by NASA. The rumour spread faster than his denial. He later admitted privately that for the first time, he felt the public's appetite for the unknown had outgrown the truth itself. As October deepened, the phenomenon spread beyond screens. Artists painted Atlas in sapphire oils. Musicians sampled static from Mars transmissions and turned them into eerie soundscapes. A fashion label even released a Comet Blue line of jackets within 2 weeks. The mystery had become a brand and belief was its currency. Somewhere the real comet continued its silent voyage through the solar system, utterly indifferent to the noise it had sparked on the small blue world trailing behind it. By Halloween, internet theorists claimed that the agencies were preparing to announce contact. Anonymous accounts hinted at encrypted files in the Mars orbiter's transmissions. When no announcement came, disappointment turned into accusation. "They're hiding it," read one viral tweet. "They're hiding everything." The algorithms fed the anger. Hope curdled into suspicion, and suspicion became conviction. Meanwhile, amid the chaos, a few quiet scientists kept looking at the raw numbers. The data was still coming, still consistent, still spectacular in its ordinariness. Yet no one wanted ordinariness anymore. The world was too enthralled by its own reflection in the mystery of Atlas. What happens when curiosity outpaces truth? when wonder becomes wildfire and the question itself burns brighter than any answer ever could. Stay close as the layers continue to peel back, because the next revelation will challenge everything we think we know, the scientist and the storm. By mid-October, 3i Atlas had vanished beyond the orbit of Earth, but down here the storm it left behind was just beginning to reach its full force. The blue image had become a kind of secular scripture, shared, dissected, believed, and at the centre of it all stood one reluctant prophet, Avi Loeb. He hadn't asked for this role, he never does, yet somehow every cosmic controversy seemed to find him, as if the universe itself enjoyed watching him wrestle with disbelief. His earlier remarks about Oumuamua years ago had already branded him the alien hunter professor. Now, reporters camped outside his Cambridge office, microphones in hand, waiting for him to say something, anything, that could turn speculation into certainty. Inside, his inbox flooded with messages ranging from heartfelt curiosity to unfiltered madness. "Professor," one email began, "if they're here, what do they want?" Another simply read, "We know you know." In the quiet hours before dawn, Loeb sat at his desk surrounded by a galaxy of screens, spectral charts, orbital maps, 1,000 unread messages. He told himself he wasn't chasing publicity. He was chasing precision. The scientist in him wanted to strip the noise away and listen for truth. Yet each new broadcast, each distorted headline dragged him back into the glare. Every word he spoke to clarify became another spark for speculation. To the public, he wasn't an astronomer anymore. He was a character in their collective dream. Meanwhile, behind closed doors, the scientific community fractured. Some colleagues defended him. He's asking the questions others are too afraid to ask. Others accused him of feeding the frenzy. Private group chats buzzed with resentment. He's making us all look like believers. At NASA and the European Space Agency, administrators held damage control meetings, scrambling to keep their projects from becoming political talking points. Funding boards whispered about credibility risks. The object, once just a point of data, now carried reputational gravity strong enough to bend entire institutions. Then came the television moment that turned tension into spectacle. On a primetime talk show, Loeb appeared opposite a charismatic pundit who accused the agencies of hiding the truth. The host leaned in, hungry for a confrontation. "Professor," he asked, "if this isn't evidence of something artificial, why does the government act like it is?" Loeb paused, a brief, thoughtful silence meant to separate science from hysteria. But the clip, edited for social media, turned that silence into a confession. Within hours, it was viral. Loeb can't deny it. The internet crowned him the unwilling oracle of a new cosmic myth. Hashtags like #LoebKnew and #The Files flooded timelines. Some treated him as a visionary, others as a heretic. Anonymous accounts claimed that his research team had been pressured to stay quiet. When he denied it, the denial itself was labelled part of the cover-up. It no longer mattered what he said. Belief had become louder than fact. Inside Loeb's office, fatigue set in. He began declining interviews, switching off his phone, walking home through the cold Massachusetts nights while students whispered as he passed. For the first time in decades, he questioned whether curiosity, his life's greatest virtue, had turned against him. Could a simple question, "What if?" ignite a chaos that drowned out discovery itself? But curiosity is contagious. Around the world, young scientists began running their own models, testing the composition of Atlas, studying the mysterious blue spectra. They didn't believe the rumours, but they couldn't ignore the excitement either. Beneath the noise, genuine inquiry began to stir again, quiet but persistent. In the middle of a digital tempest, real science flickered to life. The paradox was almost poetic. The same hysteria that threatened truth also kept it alive. Without the storm, the world might never have looked this closely at the stars. Loeb knew that, and perhaps, deep down, he forgave the chaos for following him. Still, one thought lingered in his mind as he stared out at the night sky. When a mystery becomes a mirror, are we still searching for the truth? Or just for ourselves staring back from the dark? Come with us to know the digital echo chamber. By late October, the conversation around 3i Atlas had evolved into something unrecognisable. It was no longer a debate about a comet, it had become an ecosystem, a living, breathing network of obsession. The image of the blue glow had fractured into 1,000 versions, each one slightly edited, recoloured or reinterpreted. One shimmered like plasma, another like glass. One claimed to show geometric shadows, another letters etched into the tail. The differences didn't matter. Each version claimed to be the truth. Together, they built a hall of mirrors so convincing that even the original scientists began losing sight of what was real. Every platform became its own dimension of the myth. On X, users posted countdowns to a fictional Atlas disclosure day. On TikTok, influencers filmed emotional reaction videos, tears glistening as they promised followers that everything we were taught about life will change soon. On Reddit, a 400-page investigative dossier appeared overnight, complete with fabricated agency memos and flight logs. The file was absurd, but its formatting was professional, its citations elaborate. People didn't read it for accuracy, they read it for faith. And like all faith, it spread through repetition. Each repost, each reaction, each nervous laugh on a podcast reinforced the illusion of evidence. Algorithms, blind to truth, amplified what drew the longest gaze, and what drew the longest gaze was wonder mixed with fear. The mystery had become a feedback loop powered not by discovery but by desire. It didn't need new data anymore, it only needed new believers. Inside the agencies, morale sank. NASA's social media teams stopped engaging entirely after their replies were dissected for hidden codes. The European Space Agency locked down their Mars telemetry archives, not because they hid anything, but because every missing byte was becoming an invitation for madness. Internally, researchers called the situation the Atlas paradox. The heavier the burden of truth they carried, the more the world refused to believe them. Some compared it to the Cold War UFO scares, but this was different. The internet didn't just spread the rumour, it lived it. The effect on individuals was startling. Small-town skywatchers spent their nights scanning for the comet with backyard telescopes, convinced they were part of history. A handful of opportunists claimed direct communications through radio bursts, and yet, somewhere in that chaos, something extraordinary was happening. Thousands of ordinary people had rediscovered awe. They were learning the night sky again, naming stars, plotting orbits, even reading real research papers just to understand what they saw. Science had escaped its ivory tower, but it was now dancing in a carnival. For Avi Loeb, the echo chamber became a second orbit, one he couldn't escape. His interviews were clipped, remixed, auto-tuned into pop songs. When he joked, "Maybe it's just a rock," the internet titled the clip "Professor Confirms Rock-like Alien Craft." He had become both the voice of reason and the villain of revelation. The algorithms didn't care which, they only cared that people kept watching. Meanwhile, journalists noticed something else. The frenzy wasn't dying down. Normally, digital storms burn out fast, replaced by the next scandal or meme, but Atlas had stamina. Every time the comet moved farther from Mars, its legend moved closer to Earth. The less visible it became, the louder it screamed. Each gap in official updates became proof of a cover-up. Each technical delay an act of conspiracy. Even silence had gone viral. At one point, a tech columnist wrote that the Atlas story was the first digital mythology born in real time. It was true, humanity had always built its gods from light, and now it had found a new one glowing faintly blue across the Martian dawn. Whether it was truth, trick, or shared hallucination didn't matter anymore. The meaning was in the belief, and belief had escaped containment. And so, as the real comet drifted toward Jupiter, cold, silent, magnificent, billions of people stared at their screens, waiting for something that would never come, a confession from the universe. Silence becomes evidence. It ended the way all storms do, not with thunder, but with the strange, heavy stillness that follows it. One evening the feeds were alive, pulsing with theories and arguments. By the next morning they were empty. No new posts, no leaked screenshots. The talk shows dropped their Blue Comet segments. It was as if someone had flipped a switch and dimmed the whole sky. By early November 2025, the digital roar that had followed 3i Atlas went dead. NASA's usually restless accounts posted nothing. ESA postponed its press conference, citing internal review. Even Avi Loeb, whose voice had anchored weeks of fevered speculation, fell silent. For a public addicted to hourly updates, the quiet felt wrong, less like the end of a story than the beginning of a cover-up. At first, hope disguised itself as patience. More data soon, a few optimists promised online, but when hours turned into days, patience curdled. Anonymous handles began whispering that the agencies had intercepted something remarkable in the Jupiter flyby telemetry, something that couldn't be shared. Rumours multiplied like mould in darkness. One post claimed that scientists had been ordered not to speculate publicly until confirmation from Langley. Another swore that several members of the ExoMars imaging team had gone offline. No one could prove any of it, yet the lack of proof became the proof itself. Silence, suddenly, was suspicious. Journalists tried to dig, but even the press ran into locked doors. Every inquiry met the same polite stonewall. No comment during fiscal review. A convenient excuse, perhaps, since the US government shutdown had frozen budgets and paused communications that very week. The timing was almost theatrical. While 3i Atlas swept past Jupiter, Washington went dark. No funding, no oversight. Across the Atlantic, Europe followed suit, delaying releases until the fiscal year resumes. Bureaucracy had become the perfect camouflage for mystery. Inside the observatories, the atmosphere thickened. Researchers still worked, still gathered readings, but conversation felt dangerous. Slack channels turned red only overnight. Emails that once hummed with late-night excitement now carried only clipped status lines. Data received. Processing continues. One astronomer, months later, admitted that the silence felt physical, like walking into a vacuum. In that void, imagination flourished. If scientists weren't allowed to speak, people reasoned, then surely they had found something unspeakable. Outside, the world mistook caution for conspiracy. When NASA's main site went down for routine maintenance, Reddit called it an evidence purge. When an ESA livestream glitched to static, TikTok slowed the footage frame by frame and claimed to see reflections, shapes behind the noise. Every absence became a presence. Every gap filled itself with fear. The internet, once deafening, now murmured like a seance room waiting for a ghost to answer. For Avi Loeb, the quiet pressed in like winter air. He took to walking the streets of Cambridge after midnight, the city sleeping under a wash of frost and streetlight. He knew the comet was still out there beyond Jupiter, drifting through the deep like an indifferent god. Yet even he couldn't shake the feeling that the silence itself had meaning, that perhaps the agencies really were seeing something that language wasn't ready to describe. It wasn't paranoia so much as instinct, the same instinct that had always driven him to ask questions others feared to touch. Weeks slid by. November folded into December. Christmas lights blinked where the comet's glow had once burned. The world pretended to move on. News cycles shifted. New scandals erupted. But beneath that surface chatter, the story hummed quietly, a vibration under the noise, waiting for breath or the chance to quicken it again. Somewhere, someone still had data that no one else had seen. Somewhere, an untouched file still carried the faint signature of that blue light. The silence was not an ending. It was a cocoon. Every mystery needs one before it breaks open. In every age, the unknown never dies. It only hides until curiosity finds it again. And perhaps that was the real lesson of 3i Atlas, that even silence can speak if we learn how to listen. The week without words. It began quietly, like all turning points do. On the morning of October 1st, 2025, Mars hovered pale and rust-coloured against the thin light of dawn, while hundreds of millions of miles away, a dark, slow traveller, 3i Atlas, slid silently into its closest pass. Cameras aboard the Trace Gas Orbiter and Mars Express waited for their cue, programs running, telemetry streams locked. The world had been told to expect images that could change everything, and then nothing. The data flowed as planned, bits and packets streaming down from Mars orbit, but the public dashboards froze. No new frames appeared on ESA's site. NASA's tracker page displayed a placeholder, update forthcoming. The journalists who had circled the date on their calendars refreshed the feed again and again, watching the same empty screen. Behind the scenes, the spacecraft were fine. The science teams were receiving files. Yet somehow the outside world was left staring into digital silence. At first, it seemed like a routine delay. Space missions often faced bottlenecks, bandwidth limits, data prioritization, calibration checks. But as hours turned into days, the absence grew louder. Questions turned sharp. Why no images? Reporters asked. Why the blackout? NASA cited temporary coordination with European partners. ESA mentioned data integrity review. The explanation sounded careful, too careful, like phrases written by lawyers, not scientists. Inside mission control rooms across Pasadena, Darmstadt, and Madrid, the atmosphere was tense but methodical. Engineers hunched over monitors, verifying checksums and strings, inspecting pixel noise for transmission corruption. Nothing was wrong, and yet something was wrong. An unease that came from knowing the world outside had stopped believing in coincidence. We just need to make sure the data's clean, one project lead murmured, half to herself, as if convincing not the team but the universe. Then the timing turned from inconvenient to uncanny. On October 2nd, just as 3i Atlas began its Martian flyby, the United States government shut down. Budgets froze, public affairs offices locked their doors, and social media channels across federal agencies went dark. The irony was too perfect for the internet to ignore. A comet from another star system brushed past Mars, and Earth's most powerful institutions fell silent in unison. To scientists, it was bureaucracy. To everyone else, it was proof. Online forums revived overnight. They're hiding something huge, one viral post read. Shutdown equals smokescreen. Others mapped the timeline hour by hour, drawing lines between policy memos and telemetry timestamps. The pattern seemed irresistible. Mars flyby, shutdown, silence. The rational explanation that data review takes time was drowned beneath the thrill of suspicion. Meanwhile, deep inside ESA's data analysis wing in Madrid, the truth was more mundane and far more fragile. The raw data arriving from Mars contained several anomalous sequences, frames where the object's signature appeared blurred and chromatically inconsistent. The team wasn't sure if it was a sensor issue or something in the comet's reflective halo. They needed time to verify. In normal circumstances, they would have said so openly, but these weren't normal times. Every word risked becoming fuel for chaos, so they waited, and in waiting, they built the very silence that would haunt them. A week passed. The internal network overflowed with unreviewed files. Dozens of images sat queued, unnamed, unread. Some researchers worked from home, staring at encrypted folders they weren't yet authorized to open. Others drafted tentative analyses, careful to avoid conclusions that might later be ripped apart online. "We're walking on glass," one analyst wrote in a private email. "Anything we release will be weaponized." On the outside, the world was spinning stories faster than any telescope could capture facts. Satellite enthusiasts tracked down relay signals and posted graphs claiming energy surges. Amateur astronomers shared blurry telescope shots and labelled them confirmation. None of it matched, yet it didn't have to. The silence was the story. The void had become the voice. And so, the first week of October 2025 passed without a single official image. The comet that was supposed to answer humanity's oldest question, are we alone, had instead deepened the one question no one wanted to ask: what happens when the truth itself goes offline? As October 2025 unfolded, the flyby window was closing fast. By the first week's end, engineers prepared for the final data handoff, a moment that still hung in the near future, suspended between anticipation and silence. What if the real revelation wasn't hidden in the data, but in the silence that followed it? Come with us into the next discovery. Coincidence or control? By the second week of October 2025, the silence no longer felt like a pause, it felt like policy. Inside the mission centres of Pasadena and Darmstadt, long corridors that once hummed with voices now carried only the soft whir of cooling fans. Monitors glowed with locked screensavers. A handful of engineers still came in carrying coffee cups and tired eyes, their footsteps echoing through rooms designed for excitement but now thick with restraint. What had begun as a technical delay had evolved into a bureaucratic labyrinth. Every line of code, every spectral image, every sensor log had to pass through layers of review before it could be cleared for release. The reasoning, at least on paper, was simple. To maintain public confidence, only verified findings shall be distributed. But the phrasing was cold, calculated, like a machine trying to impersonate caution. In one corner office at the European Space Agency, a communications officer named Elena Vasquez stared at an empty draft email titled Public Update on 3i Atlas. She'd been writing and deleting versions of that statement for 5 days. Each sentence she composed sounded either too vague or too revealing. Preliminary analysis underway, invited conspiracy, no anomalies detected, sounded like a lie. Even the punctuation seemed political. Finally, she deleted the message, closed her laptop, and whispered to herself, they wouldn't believe it anyway. Across the Atlantic, in Cambridge, Avi Loeb received his first official notice. Pending review, refrain from interviews or speculation concerning current interplanetary data. It wasn't an order exactly, more a carefully phrased suggestion that carried the weight of quiet threat. He'd lived through this before during the Oumuamua debates. The rhythm was familiar, discovery, doubt, debate, delay. But this time the silence had a new flavour, less scientific, more administrative, as though truth itself now required permission to speak. And in that vacuum, suspicion bloomed. Independent scientists began swapping encrypted files across private networks, each claiming to have fragments of the Mars flyby telemetry. Some were authentic, others obvious forgeries. A few showed frames streaked with interference, thin lines of indigo and gold cutting across the blackness of space. To data engineers, it looked like sensor compression artifacts. To the internet, it looked like structure, edges of a craft, a lattice, a pattern. At a closed-door meeting in Washington, mission liaisons from NASA, the Department of Energy, and the European Union gathered to discuss public stability. They weren't talking about science anymore. They were talking about reaction. How do you calm a planet that no longer trusts silence? One official suggested releasing a controlled leak to steer speculation. Another argued for transparency. Let them see everything, the truth is boring enough. No decision came. They adjourned in confusion, leaving only more room for doubt to grow. Meanwhile, the scientists tried to keep working. They focused on calibration curves, gas spectra, thermal profiles, but even the numbers felt haunted. A young researcher named Malik Jensen in Madrid noticed something odd in the telemetry timestamps, a 6-hour delay between when Mars Express logged a reading and when the same data appeared in Earth's archive. Routing delay, his supervisor said, but Jensen knew the system well. It wasn't supposed to lag that long. When he asked again the next morning, the file had been moved to a restricted folder. His access quietly expired. By mid-October, the story had fractured into 2 realities. Inside the labs, a handful of exhausted scientists struggled to confirm what the data actually said. Outside, the world had already made up its mind. One camp believed 3i Atlas was artificial, a machine gliding through the solar system. Another insisted it was proof of some natural phenomenon the agencies were too slow to interpret. But the line between theory and faith had evaporated. The world had turned belief into its own kind of evidence. Elena watched it unfold from her dim office. The media were no longer asking for facts, they were demanding sides. Who controls the truth? One headline asked. NASA's silence equals confirmation? Asked another. She scrolled through the madness, wondering when her work, words, explanations, data summaries had stopped being communication and started being camouflage. Late one night, an encrypted file pinged Loeb's inbox from a colleague at ESA. The subject line read, "Unverified frames." For your eyes only inside were 3 stills from the Mars flyby, raw and noisy but distinct, a faint azure shimmer around a black nucleus. It could have been a reflection, a sensor flare, or something entirely new. Loeb stared at it in silence, aware of the trap. To share it was to feed the hysteria. To hide it was to join the lie. Either way, the line between science and story had vanished. Outside, the public waited, restless and half certain they were being played. And perhaps they were, not by a grand conspiracy, but by coincidence itself. A government shutdown, a data delay, a blue glow, too perfect to be random, too human to be planned. But in a world starved of certainty, coincidence feels like control. And control, even when imaginary, becomes the new truth. What if the next thing they released wasn't proof or denial, but something far stranger hiding in plain sight? Stay tuned as we chase the blue ghost itself for me. Chasing the blue ghost. At first, the new data arrived unnoticed, slipping quietly through the channels from orbit around Mars. It was like every other transmission, long strings of numbers, spectral readings, compressed image packets. For a room accustomed to routine, it promised nothing extraordinary. Yet when someone finally opened the file, silence fell. On the screen floated 3i Atlas, suspended against the ochre edge of Mars, wrapped in a light that defied expectation. It was not green, not white, not the dusty glow of frozen gases. It was a piercing, electric blue that seemed impossible for any natural phenomenon. The team remained frozen, the soft hum of computers filling the void until a single voice whispered, questioning reality itself. Is that real? Analysis began immediately. Space scientists had long learned to seek ordinary explanations for extraordinary phenomena. Atmospheric distortion was the first theory to emerge. The comet's position near the Martian horizon could have caused sunlight to bend through a thin veil of dust and ice, slightly altering its apparent colour. It was a simple logical explanation, and it offered reassurance. But the reassurance evaporated when control images taken moments earlier revealed no such effect. The stars remained unaltered, confirming that the anomaly resided within the object itself. Instrument interference became the next consideration. Space cameras endure constant bombardment by cosmic radiation, and a stray high-energy particle can scatter pixels, producing ghostly colours. Yet the anomaly persisted, appearing consistently across multiple datasets. ESA's Trace Gas Orbiter captured it. NASA's MAVEN observed the same halo. Even Earth-based telescopes reflected the signature. 3 instruments, 3 independent sources, 1 impossibly vivid hue. Then a material specialist examined the spectral data and paused. The wavelength of the blue matched almost perfectly with light reflected from nickel-cobalt alloys. The same metals used in spacecraft coatings and solar sails. It was the kind of revelation that sparked imagination and dread simultaneously. A surface smooth enough to reflect light in such a way could not exist naturally on a comet. The term non-standard reflectivity quietly entered the logs, a neutral phrase for what everyone sensed but dared not articulate. Skeptics proposed the possibility of a software artifact. Perhaps a lag in one colour channel during decompression had created an illusory blue. Engineers rebuilt the image from raw telemetry, reconstructing every pixel meticulously. Yet the blue remained. Defiant, radiant, and almost deliberate, it refused to be dismissed. The anomaly could not be reduced to glitch, error, or coincidence. Each theory addressed part of the phenomenon, but the whole remained inexplicable, like trying to explain a symphony by listing its notes. Somewhere across the ocean, Avi Loeb sat in his Cambridge office, staring at the glowing images. He did not speak, he did not smile. He had witnessed similar patterns before, the initial shock, the skepticism, the retreat into caution. Yet the glow surrounding 3i Atlas seemed to pulse faintly, almost like a heartbeat hidden within the data. He made a note: coherence without symmetry, possible modulation, unexplained. Even this small acknowledgement would raise eyebrows if ever disclosed. Meanwhile, the official statement from the agencies was careful to obscure more than it revealed. Preliminary analysis indicates an optical anomaly, possibly linked to environmental or instrumental factors. Further review ongoing. Behind these words, however, the evidence continued to accumulate. New, sharper images suggested the glow was unevenly layered, perhaps emitted rather than merely reflected. Spectral analysis hinted at ionized metal particles, elements that could not belong to a simple comet. Each new observation seemed to deepen the mystery. By the week's end, the blue ghost had become a shorthand term, half jest, half reverence, encapsulating both the wonder and unease it inspired. Some argued it demonstrated the limits of current understanding. Others suspected it hinted at something far greater. The instruments, meticulously calibrated and tested, were not deceiving anyone. Something out there was shining back, and humanity had yet to find the language to interpret it. And in that quiet realization, between logic and belief, a sense of humility settled over the observers. The data was not flawed. Perhaps it was waiting patiently for humanity to evolve enough to comprehend its message. Could this blue shimmer be more than a glitch, more than an anomaly? Might it be a signal from what is yet to come? A pattern repeating until we finally learn to listen? Stay with us, because what follows is not merely new. It is the past speaking in the language of light. History repeats in silence. The silence that followed the discovery of the blue glow around 3 Atlas was familiar, but it was not the quiet of peace. It was the tense, expectant pause that comes when the universe has spoken and humanity can only murmur in response. For those who had studied the stars long enough, the rhythm of recognition was immediate. This was not a first encounter. It had happened before, and in ways that left lasting echoes. Years earlier, a cigar-shaped shadow named Oumuamua had drifted through the solar system, glinting in sunlight like a polished blade. Its motion defied expectation, accelerating as though guided by something invisible, something beyond human comprehension. Telescopes strained to track it, theories multiplied, and yet in a matter of weeks it vanished. No one could explain its shape, its behaviour, or its silence. The data quietly slipped into archives, and with it, the fervour of curiosity gradually faded. But the memory of that enigmatic visitor lingered, a blueprint for how wonder often collapses into institutional caution. Then came IM-1, plunging into the waters near Papua New Guinea and scattering fragments that shimmered under laboratory microscopes like flecks of alien metal. Avi Loeb had sailed into the Pacific himself to retrieve them, recalling the hush of the ocean at night, the rhythmic lapping of waves against the ship's hull as magnetic sleds scraped across the seabed. When the first metallic spheres appeared, no larger than BB pellets yet heavier than iron, the world collectively held its breath. And then, just as before, the phenomenon receded. Official explanations remained elusive, public consensus never solidified, and the fragments became another quiet question tucked away in scientific limbo. Now, staring at the faint cobalt haze surrounding 3I Atlas, Loeb recognised the pattern instantly. It was the same sequence unfolding again: discovery, disbelief, and dismissal. Only the stakes had grown higher. The repetition was not a cosmic coincidence, it was a mirror held up to humanity itself. Within agencies, scientists circulated the same carefully neutral phrases that had accompanied Oumuamua: non-gravitational acceleration, natural irregularity, data inconclusive. Words polished until they dulled the edges of astonishment, designed to assure the world that there was nothing extraordinary, even when the evidence suggested otherwise. Science, it seemed, had developed a reflex to conceal wonder beneath technical restraint. Yet among the analysts, a quiet rebellion persisted. In whispered conversations after long shifts, some admitted what they would never publish. The data from Atlas felt different, alive even. One engineer described it as having a pulse, another confessed that it seemed as if the numbers themselves understood those observing them. It was instinct, unease, and recognition intertwined. The precision of Atlas mocked the chaos of nature, and it could not be ignored. For Loeb, these parallels were deeply personal. He had navigated skepticism, sideways glances, and institutional warnings before. He had learned the cost of asking questions too soon, but the allure of the data was irresistible. To him, Atlas represented not just light, but a narrative repeating across time. Oumuamua's peculiar acceleration, IM-1's metallic fragments, and Atlas's cobalt glow formed a constellation of anomalies, each separated by years yet speaking in the same impossible dialect. He did not record these observations as theory, but as a conviction source. They were not random, they were echoes. Official statements arrived predictably, each phrasing measured to temper public excitement. NASA deemed the data inconclusive, ESA suggested environmental interference, and once again, the headlines cooled under the weight of institutional language. Still, the scientists closest to the data remained restless. In laboratories dimly lit by monitor glow, they compared notes, traced spectrums, and sought patterns that whispered like memories through the numbers. Beneath their analysis lingered the unspoken question: what if these events were not isolated phenomena, but chapters in a continuous narrative the universe had been composing across decades? Despite the temptation to dismiss such thoughts as fanciful, the heart of science is, in truth, romantic. It begins with curiosity and love for the unknown. Sometimes, when faced with the incomprehensible, even the most rational minds fall silent, not from doubt, but from awe. 3I Atlas drifted onward, oblivious to the debates it had ignited. The blue glow gradually faded in sunlight, leaving behind data and the growing realization that perhaps the cosmos repeats its messages deliberately, waiting for humanity to learn how to hear them. What if Three-Eyed Atlas is more than a visitor, a signal urging us to understand its message? Stay with us as this extraordinary hue begins to reveal its story. The colour paradox. As scientists delved deeper into the cobalt glow surrounding 3E Atlas, the more the phenomenon resisted comprehension. By every standard model of cometary chemistry, the hue was fundamentally impossible. Comets rich in carbon dioxide and cyanogen gas traditionally burn green, the spectral signature of carbon molecules splitting under ultraviolet light, a lesson repeated across hundreds of observations, a universal constant in the cosmos. Yet Three-Eyed Atlas ignored the rules entirely, presenting a defiance that challenged both expectation and experience. Across multiple observatories, as new spectral data streamed in, a maddening consistency emerged. The emission lines stubbornly refused to align with cyanogen or carbon dioxide, bending instead towards wavelengths characteristic of cool metals. Initially, the technicians questioned their instruments, checking filters, recalibrating sensors, reprocessing the data, even adapting algorithms designed for solar flare imaging to eliminate contamination. Each meticulous test returned the same unsettling truth: the blue light was real, persistent, and utterly alien in its behaviour. At the European Space Agency's Control Centre, senior astrophysicists compared the spectral readings to known planetary auroras. The similarity was disturbingly close, yet auroras require a magnetic field and an atmosphere to interact with solar winds, elements comets lacked entirely. It was as if Atlas carried its own physics, a miniature environment capable of producing phenomena where none should exist. When one researcher half-joked that perhaps the comet had brought its own atmosphere, the laughter that followed was uneasy, brittle, a shared acknowledgement of the unspoken. The universe was challenging their assumptions, and no one could comfortably ignore it. The theory of metallic reflection resurfaced, persistent and ghost-like. A young researcher in Prague noticed that the blue spike mirrored the spectral profiles of reflective alloys commonly used in spacecraft thermal shielding, a discovery that implied a surface smoother than any naturally occurring comet could possess. The implications were profound, yet she cautiously framed her findings in neutral scientific language, writing only, "surface reflectivity inconsistent with known comet morphology." Those attuned to the subtle warning beneath her words understood its weight. Atlas might be more than a natural object, a whisper of artificiality cloaked in measured terminology. Meanwhile, Avi Loeb in Cambridge scrutinised the readings through the quiet hours of the night, the soft hum of his computer filling the room with a meditative rhythm. Comets could glow green, white, or gold, but never blue. Blue was the colour of metals, of controlled reflection, of deliberate design, a signature that suggested intent rather than chance. He recorded observations with careful restraint, aware from experience that revelation often demanded patience, allowing questions to settle and ripple before daring to speak them aloud. The question itself lingered like a star on the horizon. What kind of object could emit blue light in the vacuum of space? The arrival of further data only deepened the contradictions. If the glow originated from metallic reflection, temperature measurements were inconsistent. The comet was far too cold to produce such light. If chemical in origin, expected trace gases were absent. Every explanation seemed to consume itself, leaving uncertainty intact. One researcher finally voiced the thought that had haunted everyone silently. Perhaps this was an object that did not wish to be seen clearly, a phenomenon resisting definition, eluding comprehension, demanding a new way of thinking. Weeks passed with agencies releasing carefully constructed statements, promises of calibration, and ongoing investigations that said nothing while implying everything. To the public, the wonder of Atlas faded, yet within the observatories, fascination intensified. The discussion was no longer about colour or chemistry. The blue light had become a mirror reflecting the limits of human understanding, a challenge to perception itself. Somewhere within the spectral shimmer lay a paradox, a phenomenon at once natural and unnatural, innocent and seemingly intelligent, impossible yet undeniable. As images from live feeds faded and silence returned, scientists confronted a quiet revelation. The universe had reminded them of its vastness, its capacity to elude, and the humility required to face what could not yet be named. Perhaps the blue light was never meant to illuminate Atlas alone. Perhaps it was intended to illuminate humanity, to confront fear, pride, and the fragile belief that the unknown had already been mapped and catalogued. This colour may reflect not the comet, but ourselves, pushing us to see beyond what we know. Stay with us as we turn from the science to the people confronting the impossible. The human element. Within the control rooms that once pulsed with the electric energy of discovery, a different kind of silence had taken hold, one that was neither celebratory nor peaceful, but weighted with doubt and quiet reflection. The men and women who had dedicated their lives to decoding the cosmos now found themselves suspended between understanding and mystery, their instruments whispering truths that no theory could fully contain. 3. Atlas had ceased to be simply an object to study. It had become a mirror reflecting the very limits of human certainty, revealing gaps in knowledge that had long been ignored or conveniently overlooked. In a dim corner of the European Space Operations Centre, Clara, a young analyst, remained at her terminal through another endless night shift, the gentle hum of machinery and the subtle click of her keyboard the only interruptions to the prevailing stillness. Her gaze lingered on the spectral graphs of the blue emission lines, tracing patterns that refused to conform to established laws of physics, a defiance that contradicted everything she had been taught since her earliest training. Each recalibration, each careful reprocessing of data, returned the same confounding result: wavelengths that should not exist, light curves bending the rules of expectation and experience. A quiet tension simmered beneath the surface, a rebellion against the comforting notion that everything could ultimately be explained if only one searched long and hard enough. The blue glow of 3i Atlas had shattered that illusion entirely, leaving only awe interlaced with unease. Across the Atlantic, at NASA's Jet Propulsion Laboratory, Dr. Adrian Valdez sat in the dim glow of telemetry screens, rubbing his temples as endless streams of numbers scrolled past. He had always regarded data as the purest form of truth, believing that numbers, unlike opinion, could not deceive. Yet as Atlas continued its luminous trajectory, the readings began to resemble riddles crafted by some unseen hand, teasing comprehension while withholding certainty. He considered the students he had once mentored, filled with idealism and the belief that the universe could be neatly decoded. He wondered what he could now tell them, except that sometimes the puzzle does not yield and the pieces refuse to fit, leaving even the most seasoned observer to wrestle with the profound discomfort of the unknown. Casual conversations between colleagues had become increasingly rare, replaced by careful, measured exchanges, a brittle politeness reminiscent of diplomats negotiating a delicate truce. Laughter had all but disappeared, replaced by an unspoken tension that acknowledged the discomfort no one dared voice. The mystery of Atlas might not be a failure of measurement or methodology, but a failure of imagination. Perhaps humanity had reached the edge of comprehension, and no amount of instrumentation could bridge the gap between knowing and understanding. And yet, amid the exhaustion and tension, fascination persisted, a quiet, almost imperceptible awe that could not be muted by bureaucracy or protocol. In private exchanges, some researchers admitted that the data haunted them in ways that logic alone could not explain. A computational linguist working on translation scripts described the readings as a rhythm hidden within noise, while an astrophysicist compared Atlas's orbit to a delicate dance, precise and purposeful as though the object navigated rather than drifted. Night after night they returned to the screens, drawn by a force they could not define, a compulsion reminiscent of a moth circling the flame that both entices and threatens. Avi Loeb, meanwhile, seemed almost spectral, pacing the quiet hours in Cambridge beneath the soft glow of his office lamp. He no longer sought attention or public validation, having learned restraint from past encounters with phenomena such as Oumuamua, yet the questions remained, burning and unyielding. Was 3i Atlas merely another fragment of cosmic debris, or was it a messenger, conveying information not through words or signals, but through the very impossibility of its existence? He refrained from recording such speculations. Some truths he knew required patience, awaiting for a time when the world could read them, without fear or skepticism. For the younger generation of scientists, Atlas ignited a different kind of emotion, less burdened by disbelief and more alive with wonder. To them, the phenomenon represented a rekindling of mystery, a reminder that the universe still held secrets beyond established knowledge. A graduate student at the Max Planck Institute wrote that studying Atlas felt like standing at the edge of a new language, while another compared it to hearing music for the first time, familiar yet alien, human yet inhuman. Their innocence and openness, untainted by fear of ridicule, reminded the scientific community that uncertainty was not failure, but freedom, a doorway into discovery. Outside the observatories, public attention shifted between intrigue and impatience. The absence of definitive statements, the reluctance to name the object, and the silence of official channels fueled speculation. Yet within the labs, a subtler transformation was underway. Scientists accustomed to certainty were rediscovering humility, sensing in the quiet moments between data streams and equations a profoundly human presence, the recognition that curiosity itself, unshackled by ego or expectation, was the most vital instrument of all. They were not merely chasing light, they were chasing understanding, and the pursuit, though arduous and disquieting, was sacred. As weeks turned to months, 3i Atlas drifted further from Mars, its glow dimming as it retreated into the cold expanse of interstellar space. Eventually, the object became what all mysteries ultimately become, a story, recorded in fleeting images and fragmented readings. Yet the people who observed it, their attention, their doubt, and their imagination had been irrevocably changed. They had confronted something beyond language, beyond conventional measurement, and in doing so rediscovered the essence of science, not the resolution of questions, but the perpetuation of wonder and the unrelenting drive to seek, to question, and to imagine. 3. Atlas drifts silently through space, reflecting the curiosity and courage of those who studied it. The true discovery lies not in the comet, but in humanity's relentless pursuit of understanding. Stay with us for the final chapter, What the Universe Meant. When the last image of 3i Atlas faded from the monitors, it felt less like a conclusion and more like a quiet farewell. The data streams thinned, the control rooms fell silent, and the object drifted back into the infinite dark, a faint shimmer swallowed by eternity. No official statement would ever define it, and no headline could capture its essence. Perhaps that was precisely the point. The universe does not hand us answers, it only asks us to listen, to pay attention to its subtle cues. Every comet, every flash of impossible colour, every anomaly is a question in disguise, a whisper reminding humanity that discovery is not mastery but connection. 3i Atlas entered our solar system like a silent visitor, left us nothing tangible, yet carried a resonance far deeper than words could express. Months passed, and scientists debated, tested, and recalibrated, trying to force the enigmatic blue light into the frameworks they knew. Yet beneath the numbers and graphs, a quiet understanding began to bloom. They had arrived at the edge of knowledge and discovered something unexpected. Wonder. They glimpsed the boundary where certainty ends and imagination begins, realizing that humility, not control, is the true companion of exploration. In moments of solitude, some admitted to themselves that perhaps 3i Atlas was never meant to be solved. Perhaps its purpose was to remind us that despite centuries of study, we remain children under a sky that will not yield all its secrets. The unknown is not an enemy, it is a mirror, reflecting not only what exists in the cosmos, but what resides in ourselves, our curiosity, our audacity, and our desire to understand. And so 3i Atlas drifted onward, its mysterious glow fading into memory, leaving no evidence but the traces of its impact on human minds. The people who witnessed it were forever changed. They would build new instruments, chase new stars, and draft new theories, but the memory of that impossible blue light would remain, a reminder that the universe listens, and sometimes it answers in the only way it knows how, by showing us ourselves. Was the light merely a reflection of a distant object, or was it a reflection of us, our imagination, our yearning, our relentless need to believe that somewhere in the cosmos, Our curiosity is met with a silent, knowing gaze. The universe had spoken. We had only to hear. 3. The atlas is gone, but its blue glow still haunts the questions it left behind. Was it a natural wonder, or something far beyond our understanding? What do you believe the truth behind 3i Atlas really is? Share your thoughts below. The mystery is far from over.